Okay, so today we're talking about log properties, and here's the big properties. The one that I haven't explained much is number 7. Look at number 7, please. On the other list that I made that was just like this yesterday, I said that the answer was 0 when B was 0. In other words, if I put a 0 right here, you can't get an answer. It's not like the answer is 0. The answer is there's no answer. So what can A be? And what can B be? Well, A and B cannot be 0. I'll tell you that. If A is 0, you got a problem. A can't be 0. B cannot be 0. Otherwise, you'll have no answer. A cannot be negative. And B cannot be negative. So another way to say that is that A has to be greater than 0. And B has to be greater than 0. Otherwise, it will have no answer. So it'll have no answer if A is less than 0 or B is less than 0. You will have a problem. Or equal to, actually. Because if it's equal to 0, you'll still have a problem. Alright, so if you see this problem and you're struggling with it, you shouldn't be. So what's the answer? No solution. Can't do it. Or how about this? Some kids are going to say that answer is 1. Because, oh, those two are the same. And when those two are the same, the answer is 1. No, you can't have zeros in those spots. So the right answer is no answer. Okay. All right, so let's go back to these. Any other things you want to ask about of these properties? Don't quite explain or understand one. Yes?
Well, do we get the calculator?
Calculators are not allowed. So that means that you can't, like when you want to figure out one of these kind, like this, they might ask you, what could you type in your calculator to get the answer? So let's talk about the base change for just a second. Let's say it was log base 3 of 7. I don't expect you to be a calculator. You don't have the decimal for that. But you should be able to know what you would put in the calculator. What would you put in? Log 7 over log 3. Would it be okay to say ln 7 over ln 3? Yes, because that's just got a different base. And you can have any base you want. Would it be okay to say log base 52 of 7 over log base 52 of 3? Yeah, but if they, in the context of putting that in the calculator, that wouldn't be okay, because your calculator can't do base 52. So this would be a correct answer, but not if the question was, what could you put in your calculator? All right. Let's move on and do some more stuff I've got prepared for you. Changing back and forth between forms is like the first thing I showed you how to do. If it's an exponential, you can make a log out of it. If it's a log, you can make an exponential out of it. So would you take this one, please, right here, and make it into a log, and then, without a calculator, evaluate it, which means tell me the answer. Okay, so the first thing you want to do is say log base 9 of 1/3 equals x. Notice we go from here over to here and then back over to here. Okay? Now if I had a calc, I'd just type in log of 0.3 repeating divided by log of 9 and I had my answer. But you can't do that. Wouldn't it have been nice if I would have made this 1/3 be a 9, and then it'd be log base 9 of 9, and then it'd be easy, right? The answer would be 1. So, who's got an idea of what I could do? Make the 1/3 a 9. How do I do that? I can make the 1/3 into a 9 to the something. To the negative. Now if I made it -2, I heard somebody say that would be 1 over 81. So what do you think? Negative 1/2. 9 to the negative 1/2 power. Why? Because what is 9 to the 1/2 power? 3. And then the negative makes it flip, 1/3. Now that I've written it that way, can you see the answer is negative 1/2? All right. Okay, instead of doing a log thing. All right, so you would have said, I just want to figure out that 9 to the 1/2 power, negative 1/2 power is 1/3. That'd be fine, unless it told you that you had to rewrite it. And you could still do it this way. You could still figure out what that has to be, but you got to be able to transform between forms. So for instance, if I say 5 to the x equals b, you should be able to rewrite that as a log. Because you're not always going to like figure that one out in your head. Okay, I can't, but I can rewrite it as a log. Log base 5 of b is x. And now I've got it solved for x. All right, so you need to know that too, but I get you that if you want to just look at this problem and say, oh, I can tell what x is in my head. That's okay, unless it specifically asks you to rewrite it as a log. Okay, now this one's a log. Please rewrite it as an exponential. It seems like it's missing a part that's kind of important. What is it missing? Equals x. Now I can rewrite it as 8 to the x equals 40. Raise your hand if you had that one right. Okay, good. That's an exponential coming from a log. Now, what's the decimal answer right there? Well, I don't know. But how about this? Could I ask you to estimate it? Is 1 big enough? 8 to the 1 would be 8. How about 8 to the 2nd power? What would that be? 64. That's too big. So can you get that the answer is between 1 and 2? All right. That'd be good enough. I would not expect you to be able to use a calculator and know that the decimal is like 1.4432 because you can't use a calculator. Yes, sir? No, I'd say that it's reasonable for you to say that the answer is between 1 and 2.
How do you find that
On a calculator. You'd go back to the other form. This is one of these where option A or option B, which one goes in the calculator? Option A.
How do you type log 8?
You would type in log 40, remember this, over log 8. That's the base change thing, okay? All right, moving on to, here's some more prep for the test. This is something that's going to come up a lot, and it's amazing how many kids struggle with, well, what does that mean? I think anytime you see ln, to try to figure out a problem like this, you should rewrite that as log, what? Base e. If you write log base e of e, now I bet you can tell me what the answer is like right now. What is it? The answer is 1. Why is it 1? Because these two are the same, so the answer is whatever exponent is on that. What the exponent is on that? A 1. And therefore the answer is 1. So what is ln e? Whenever you see this, what is it? It's 1. The answer is 1. Just 1. Oh, if you were going to graph this, if it was y equals ln e, it's a good point. Y equals 1. It'd be a straight line. All right. This is called evaluating. It means give me the answer as a number. All right. But this one. This is one of those kind where it'd be really nice if I'd have used a 5 right here, but I didn't. But you could make me use a 5 right there. Try it on your paper. Rewrite this with a 5 right there, and you'll be able to know the answer. Easy peasy. Is the correct next to words pumpkin squeezy? Or lemon squeezy? Lemon squeezy. Okay, my daughter started using pumpkin, so I didn't know whether that was the correct vernacular. Easy peasy. Lemon squeezy is apparently correct. Log base 5 of 5 to the something. Well, 5 to the what? How do I get the 25, first of all? That's got to be squared. And then how do I get it to be 1 over 25? So the final answer is that's equal to what? Negative 2. In other words, if you were able to use a calculator to do this, and you type this in the calculator, your answer would be negative 2. All right. Look at this one. If you're struggling with one because it's a property, and you may not remember it, what do you do when you forgot a property? You set it equal to what? And then you rewrite the thing as an exponential. You go what to the what equals what, and then you figure it out. If you don't know the answer, do that. Other hint I gave you was log e is the same as n, or ln, sorry. And now I can rewrite this thing, e to the x equals 1, and how many of you knew that the answer was 0? Raise your hand if you did. All right, that's half the class. That means half of you get this wrong. That's a property, folks. See that having a 1 right there? Yeah, remember that up here? Bingo! You got to recognize that one. It's 0. Okay? So whenever there's a 1 right here, no matter what the base was, answer is 0. All right. Moving on. How about that one? Please write down what you think the right answer is for that one. Grab your pencil. Use paper. Some of you are way overthinking it. Who's got the answer? And you know you got the answer. 5 people are confident? Oh, come on. What do you think it is? No answer. Why is there no answer? Ah, can't have a negative right there, can ya? See? These properties aren't that hard, but there's a lot of them to remember. It's easy to forget. All right, this next one. Remember what I said? Whenever you see ln, you should probably write it as what? Log base e. So this is really e to the log base e of 5. Do you see it now? 5. Answer's 5. Because if these two are the same as each other, then that's the answer. Okay, and what's the final answer there? That one right there. What's the answer? 5. All right, moving on. Base change. Would you change this base to something you would put into a calculator? Just change it to something you'd put into the calculator. How could you put this in? Right now it's base 7. Your calculator can't do base 7, but it can do base 10. So you could say log 9 over log 7, right? Now, what if I asked you to change it to a natural log? ln 9 over ln 7. All right, that one. Change it to base 17. I just showed you how to change a base. First I changed it to base 10. Then I changed it to base e. Now I want you to do the same kind of thing, except I want you to change it to base 17. So how do you do base change? You go log 17 over log 5. But what's wrong with that? That's base 10. So don't make it base 10. Make it base what? 17. So how many of you wrote that? All right, good. You're all wrong. Who can? Oh, you got it? That's right, because that's equal to 1, isn't it? 1 over log base 17 with a 5 there. All right, now let's just look at what we just did. All we did here was say, oh, that's a property. That's equal to 1. Now, look at back to the original question. Log base 5 of 17 is equal to 1 over log base 17 of 5. See what happened there? The numbers just switch places, and you put 1 over it. That's not a property. It could be. But it's something that would happen. Again, if I, for instance, did... Let me get rid of this stuff. Throw that in the trash. Go. If I said log base 9 of 24, that'd be equal to 1 over... What? log base 24 of 9. Hey, we just figured out a new property. All right. Not a required property to know. But am I expecting you to know how to change it to base 17? Absolutely. And am I expecting you to notice things like if these two are the same, then I can change that whole thing into a 1? Yeah, you need to be able to do that. That'd be a really easy mistake to make too. All right, moving on. Expanding this. Well, wait a minute. There's only one thing, 27. But couldn't I write the 27 as something else? What could I make the 27 into? Two things you could make it into. Give me either one. There's actually 4 things you can make it into. Give me something 27 is. 3 to 3 cubed. 27 is 3 cubed. Do you get that? Now why would we do that? Because now if we want to expand this out, remember the power rule? Do you remember that when you have a power like this, it can go where? Down to the front. So the final answer would be 3 log 3. And what about the kid who says, but I chose to expand it by taking my 27 and making it into a 9 times 3. And then I can split it up into log 9 plus log 3. Are they also right? Yes, they are. That's okay. There's nothing wrong with that. This is also expanded. They're both expanded. They're just expanded in different ways. All right, let's look at this one. This one, it's just too brutal, too complicated. I'm going to get the x cubed out of here and just make it log base 3 of 3x over 8y. See if you can expand that out. Do you remember that when they're subtracts, or sorry, when they're divided bys, then they change into subtracts? Base 3 of 3x minus log base 3 of 8y. You get that? I just changed the big divide into a subtract. You can do that. That's the quotient rule. All right, now do you get that this one can be broken up into 2 parts? And this one can be broken up into 2 parts? See if you can write your final answer. I'll see if you're right. And I know some of you are going to make a mistake. So try to catch it before I catch it. Alright, this one can be broken up into log base 3 of 3 plus log base 3 of x. And this one over here can be broken up into log base 3 of 8 plus log base 3 of y. That got really squishy at the end there, sorry. What am I intentionally not putting in yet? Yeah, I need a negative here, and this is all in parentheses. Because if you just put a negative on the first one, what about this one? That one's also got to be subtracted. Okay, so you need a parentheses there. And there's one more little thing. Did anybody catch it? Ooh, you caught it. Yes. Right there, what's that equal to? 1. Now, if you don't notice something like that, you can potentially crash your whole R3 because you forgot one little thing. So, yeah, there's a lot of things to remember. Yes?
How come you don't bring the x or the 8 or the y to the front?
Good question. Could we rearrange this and put like this in the front? Could if you wanted to. How would you pick what goes to front?
Well, I mean, like the x. Is it the power?
Oh! If you thought that that x was a power, then it's only because I wrote it badly. This is supposed to be a little base of 3, and this is supposed to just be a normal x that has no power on it.
Okay.
Okay. All right. That was a pretty tough one. This one, much more doable. That's like, you know, I could definitely see that as a test question tomorrow. Try it. Only one hint so people don't spend forever on this. If you leave m as a square root, it won't work. You gotta make it m to the what? What is square root the same as? What power? 1/2. Again, little algebra stuff that you need to know, like that. So this automatically should start with that. That's why I made that Algebra Ninja thing, to remind you of all the little things you gotta know. There's a lot to remember. If you keep it all fresh in your mind by reminding you every now and then, you will remember them, and it will be easy. All right, first thing I would do is make this divide here turn into a minus. ln of m to the 1/2 minus ln x. Then I can't leave it that way because it's not expanded all the way. Now I got to take that 1/2 and throw it out front. 1/2 ln of m minus ln of x, and I'm done. Raise your hand if you had that one. All right, good. Yes? I would not want you to do that, but I wouldn't mark it wrong. Because log base e and ln are the same thing. And you kind of even have a point about it is expanding it, kind of. So I would give it to you. But generally speaking, you shouldn't leave an answer with a log base e in it. It's kind of like an unsimplified fraction. Log base e is supposed to be written as ln. It's just sometimes when you have an ln in the first place, it helps to substitute that in for a second to see what's going on. But when you're all said and done, you should leave your answer with an ln. All right, moving on. Condensing. That's taking something that's big and spread out and shrinking it down to a simpler problem. Try this one. This is like so big. How do you eat an elephant? One bite at a time. And hopefully roasted, because raw wouldn't be very good. So you might want to look at this part and say, could I make that part simpler? Like, figure out what that would condense down to? Would you agree that this 3 out front could go on the x? And this 2 out front could go on the 2 on the y? That's the power rule going backwards. And then it's ln x cubed minus ln y squared. And then that part right there, that can be made into a fraction. ln of x cubed over y squared. You get that? And now, to the other side. Can I find anything to make that simpler? Yeah, I can. I can go ln x plus ln of y to the 1/2. That is the same as the square root of y if you wanted to do that, but you don't have to. Then, can I put them together? Yes, they're a plus, so I can put them together and make them a times. X times y to the 1/2. All right, now I've simplified the left side, and I got this. I simplified the right side, and I got this. And now I need to subtract. What does subtract turn back into? Division. So it's a big divide. ln of x cubed over y squared all over x y to the 1/2. Whew, brutal. Again, here's the left side. Here's the right side. Now, I oftentimes will just tell you what's going on in my head. I'm thinking to myself, can't I put this big fraction into, like, flip it and multiply? I'm not sure if you even should, because these logs can be tricky about what you're allowed to do and what you're not allowed to do. So I would say that this would have been a good enough answer. I'm not even sure if it would be mathematically correct in a log to be able to change this into a multiply the yellow, flip the red one over and make it 1 over that and multiply it by the green one. I'm not sure if that would even worked. They get tricky. All right, that's a little over the top, but I showed you a whole bunch of things in it so that, you know, I don't think you'd have to do anything quite that bad. Maybe, but not that likely. No, this isn't R4 because we've learned all this stuff. If they want to make it an R4, they'd throw in something you haven't even done before, and it's close. A little too easy for an R4. Maybe a little too hard for an R3. All right. What if your answer has to be in natural logs? Done this one before. If you recognize it, it's easy. I'm tempted to write log 5 over log 6. Why can't I do that? Because not in natural logs. So how do I change it to be a natural logs? Just go to put a base E on it if I want to. So then it's ln 5 over ln 6. How many had that one right? Ah, there's hope for humanity. Yes? Good question.
Is that part of condensing?
Yeah, if you have an ln on the top and an ln on the bottom, don't do that. You got to get it down to 1. It's like if I look at the original condensing kind of problems, like right there, or expanding problems, they only have 1 log, see? So if you find yourself at the end of a problem and you've got like log of xy over log of m squared, put the logs together as 1 log. Log of xy over m squared, like that. Okay? This left this way would be wrong, because it's not condensed all the way.
So why haven't you been doing that for the base?
I have been doing that. Oh, I got you. Okay, I got you. Base changes. So if we take, for instance, log base 5 of 9. All right. So are you saying you want me to say instead of log 9 over log 5 that you want me to write log 9/5? Is that what you're saying? All right. So this problem is like, what would you type in the calculator? So if the question is, what could you enter in your calculator, then log 9 over log 5 makes sense. Log of 9/5 might also work. Don't know. I think we should find out right now. I'm going to have different people try different things. Who's got the calculator out? You do. Would you type in log 9? Who else has a calculator out? Would you type in log 5? And who else has a calculator out? Back corner. Would you type in log, put in parentheses, 9/5? All right, what's log 9? What is log 5? Would somebody divide these two now? Those of you with the calculator. And what do you have for your final answer for log of 9/5? I can tell right now that's not going to be 0.255. Okay. So, better stick with this. Back to the thing you were originally talking about. Was this kind, you should not put the logs together. When you are condensing, you should put the logs together. Yeah, it'll say condense or expand. And if you're condensing, you're trying to get it down to a nice condensed, simple. This one doesn't look very condensed, but usually they look more like, you know, ln of x squared y over p. It's just condensed down. And if it's expanded out, you'll know it. It's really big and long.
Well, if we
the directions will say, they're very clear. The problem is not what should I do, it's usually just, it's getting complicated because there's this fraction and a fraction, and anyway. What happens is there is a fraction and a fraction. Do you know what to do? We just talked about how we're not always going to be able to, you know, do a condense like this, but do you know what you're supposed to do with the normal fractions, 1/2 over 3/4? Either 1/2 times what? 4/3. Or you can multiply both of them by something. What could you multiply the top and bottom by that would fix my problem? Multiply by 4 on the top and 4 on the bottom. And that way I'd have 1/2 of 4 would be 2, and 3/4 of 4 would be 3. Either way it works. Another one of those little basic algebra skills. You got to be able to handle a fraction and a fraction. Okay, and we are done because now it starts talking about graphing, and we are not taking the graphing test. So, your homework is this worksheet I'm about to give you. It is called Properties Number 3, Practice Worksheet. It'll be very handy.